Hello, and thank you for visiting this virtual poster presentation at MARAC Fall 2024. My name is Michael Andrick. I am the Lone Ranger Archivist at the Ukrainian History and Education Center in Somerset, New Jersey. And this is about our recent implementation of PBCore for audio cataloging. The UHEC is an interdisciplinary organization spanning the arts and the humanities. But most importantly, for the purposes of this poster, we have one of the largest collections of Ukrainian recorded sound pretty much anywhere in the world, which we have been digitizing the at-risk magnetic recordings for about 10 years now. So we have all of the typical needs that a institution doing audio digitization has, namely cataloging the physical media, tracking digitization, maintaining metadata, and since we are doing digitization in-house, that means being able to create descriptive metadata on the fly simultaneously with digitization. And we do not have a DAMS or an institutional repository to help with that. So in some ways, this poster is a follow-up to the talk which I gave at the Spring 2023 MARAC. At the end of that talk, I commented that our current workflow was cumbersome, clunky, and probably not sustainable. But that at that point, we really weren't sure what to replace it with. Well, this is our proposed replacement. It is based on PBCore, which is a well-established cataloging standard specific to audio and video content. It has lots of really cool features, but the existing PBCore implementations that are out there really didn't work sense for us. Completely explaining the details of PBCore would obviously be way beyond the scope of this poster. However, there are some key concepts that are really important to understand. One of which is that PBCore makes a distinction between an asset, which is an abstract entity, and an instantiation, which is an actual item of physical or digital content. So just for some concrete examples, asset metadata could include a title, date of creation or date of broadcast, a description, creators or contributors, subject headings, rights statements. Metadata for a physical instantiation could include the media type, any labels or annotations, its technical details, what its status is. We might have preservation events associated with that physical instantiation. And then obviously some sort of identifier linking back to the associated asset. A digital instantiation could include what the purpose of the file is, technical metadata on the actual file itself, how it was created, preservation metadata, and then again, linkage to the assets and or instantiations that it was derived from. So you might ask, how is this different from just entering all this data into a bunch of spreadsheets? Well, the key thing is that they are linked via these asset and instantiation identifiers. Furthermore, some of the metadata appear in multiple places, such as controlled vocabulary terms, rights statements, things like that, which we hopefully would only want to change once if we needed to change them. This naturally leads to a relational database type of strategy, but we certainly didn't want to be implementing an entirely new database application from scratch. So what we decided to go with is something called Grist. It is a cloud service as well as an open source software that provides a no-code or low-code database spreadsheet hybrid. So here's a little piece of a physical instantiation table where on the left we have a physical instantiation identifier. We have the technical details of the media itself. We have transcribed label information, and we can create similar tables for assets and for digital instantiations. But where Grist really shines is that we can take these spreadsheet type things and make forms out of them. And these forms aren't just for display. They are actually fully editable, and any edits that you make get saved right back to the database. So here on the left, I have just a list of physical instantiations. If we click on one of them, the forms on the middle and the right populate with all of the associated metadata associated with that physical instantiation. So we have all the metadata for the asset to which that physical instantiation belongs, and we also have the physical instantiation preservation events. In this case, I happen to add some leader tape to it. And the various pieces of metadata here are in fact not just controlled value lists, but they're actually links to another table. So for example, we have a table of authorities, and you can see where Dmytro Korbutyak not only just has his authorized name, but also his LC name authority identifier, his Wikidata identifier. We can also view all of the technical details of the digital instantiations. So same idea, we can click on a physical instantiation on the left, and we can get a listing of all the digital instantiations associated with that physical instantiation. So in conclusion, Grist has allowed us to consolidate and clean up all of our legacy audio metadata. I haven't really talked about the cleanup here because that's beyond the scope of this poster, and this does seem to be robust enough for production metadata creation and a more sustainable and viable option going forward. Thank you.